Okay, hey everyone, welcome to XARPANET's platform overview. My name is Chris Matthew, and I'm going to walk you through our brand new XR Spatial Web platform. First, we'll do an intro video and a demo, and then we'll walk through 5 sections, walking through the various components of the XARPANET stack. And we'll go from there with Q&As in between each section. So let me get started with the intro.
I've had my share of moonshots to date. I've built and sold 5 companies. My previous company, Computes Inc., was a decentralized mesh supercomputing platform that I sold to Magic Leap in 2018. My next moonshot is called XARPANET, and I'm building the world's first XR spatial web. Up until now, the web has been locked in screens. We're freeing that now with XARPANET, bringing the web to the real world web, by building an XR cloud that allows you to pin digital content and spatial apps to geolocation coordinates anywhere in the world, viewable by any AR device using WebXR technologies and an open plugin architecture. Also, VR users like Oculus and Vive will be able to teleport to any geolocation coordinate in the world. They'll see the real streets, the real buildings, the real trees, and digital content also pinned to those locations. One more component is that avatars will exist in both worlds. AR users will see VR users in the real world as avatars, and vice versa. VR users will see AR users in the world as well. It's built on top of IoT technologies such as MQTT to create billions of devices and people being able to communicate on the same level in a spatial messaging platform powered by these XR browsers, powered by the XR cloud. So join me in bringing XARPANET to reality.
All right, so we will show you a brief demo here of what we did with Adobe's Aero product integrated with XARPANET.
Hi, Chris Matthew here from XARPANET, the XR spatial web company. I'd like to demonstrate how Adobe Aero plus XARPANET could become the Instagram of the real world. Let's check it out. Okay, I'm playing with Adobe Aero outdoors, right outside of my home. And I created a little robot scene. He's got a little bookshelf with him. I'm gonna put him right there outside my home. There he is, he looks happy. And we'll pin him to this lat long in XARPANET. Okay, so I exported the robot using USDZ format. I used Adobe Dimension to convert USDZ to GLTF. And then we used the XARPANET API to pin a GLTF, the robot GLTF, to this lat long right in front of my house. So if I hit send, there we go. Now we have an XR cloud representation of the robot anchor pinned to the lat long. Okay, now that we pinned the Adobe Aero content to a lat long, now I can load XARPANET's browser on my Mac or via Oculus or Quest and go into a specific address which will correspond to a lat long, and I can teleport in VR to this address, and sure enough, there's the Adobe Aero scene, my robot and a bookshelf in VR. So, I mean, if you kind of look around, I live at the end of a dead end, not a whole lot of houses around, but there's a water tower over here, there's other homes right here, and here's my home. It could be a little bit higher fidelity, but that's a block structure representation of my home based on OpenStreetMaps. And there is the Adobe Aero robot right out front. Okay, so I stepped outside and I'm on my iPhone Safari web browser.
looking at the XARPANET browser, and as you can see, there's a pin, an arrow pin in the middle of my vicinity. If I zoom into reality mode, you'll see there's two black dots. One black dot is me physically here. The other black dot is my VR friend who's teleported to join me. So if we zoom in to reality mode, it should start asking us to approve a couple of permissions like the mic and camera access.
Okay, so as we look around, there is the Adobe Aero content pinned outside of my home as we had it originally through XARPANET. And if we look around here, you'll see the avatar of my VR experience teleported into the real world. So now you have both VR and AR able to communicate at an exact lat long and interact with Adobe Aero content, the Instagram of the real world. Okay, well, hopefully you're just as excited as I am, as this could be the beginning of the Arrowverse. Not only digital content being able to be experienced in XR, both VR and AR, and users being able to interact as avatars. Imagine higher fidelity avatars, like life-size avatars. Imagine IoT devices being able to communicate in real time with content, sensors, actuators, etc., robots. This is the beginning, and I'm excited to see what a higher fidelity implementation of this looks like with seamless Adobe Aero integration. So stay tuned.
Cool. So that's the intro and the demo. I'm going to walk you. We've got 5 sections that talk about the various components of the stack that make this all happen. So let me get started with the XR browser. So this is the VR and AR browsers that interact with the world. So I'm going to play it, but then I have a couple of extra live demos I wanted to do right after that, and then we'll pause for a Q&A. Okay.
Hey, Chris Matthew here. So now you've seen the intro. I'm going to walk you through XARPANET's XR Spatial Web Platform in more detail. So what we've created is a world-scale XR spatial anchors and spatial messaging platform for both AR and VR users. So there's a digital twin of the real world. You can teleport there in VR to any address or lat long in the world. If you're physically there, you have a map with anchors pinned on the map that you can zoom in and see in the real world. And if you've got people both in AR and in VR, you can collaborate and connect as avatars in both the VR and AR space. So I'm going to walk you through how all of this works together. The technology is basically 4 main components. So there's a VR browser, an AR browser, an XR cloud that connects them all together with GLTFs as anchors. And then we've got a web crawler that makes it easy to bring, Web 2.0 type web addresses into this new Web 3.0 spatial web. And then interconnecting all of these services is a spatially aware messaging platform that's built using IoT MQTT protocols to scale at supporting billions of instances at the same time. Not only humans interacting with other humans in locations, but also IoT devices, chirping certain things, or even anchors, with the spatial web engine, being able to have anchors communicating to people in those vicinities. So I'm going to walk you through that. XARPANET is based entirely on web protocols. So we've got basically an MMO platform, multi-user platform that supports real-time messaging, as I mentioned before. There's WebRTC components, WebXR components that allows you to run this on any Mac, PC, Linux operating systems, Oculus and Vive for immersive VR, phones and tablets for AR, iOS and Android, as well as augmented reality immersive headsets such as Magic Leap and HoloLens. So this is kind of what it looks like. Basically, what we're seeing here is a Mac user, an iPhone, an Oculus, and an ML1, Magic Leap 1, all working together or in the same space in a digital twin in a space. So the avatars are pretty rudimentary at the moment. They're just kind of like little spheres with eyeballs, but they do headset tracking. So if you look up, your little avatar looks up, side to side, etc. So, and that you notice that little VR icon in the bottom right, these are immersive. So if you are running a VR device or an AR device, you click on that and it turns into a full 360-degree presence of that space in the device. For mobile users, XARPANET's browser detects that you're on an iPhone or a mobile device or a tablet. So then it switches into AR type experience where it gives you a map of your current location and pins of all the GLTF spatial anchors that are pinned to lat longs near you. Notice there is a listening radius that's set, and I'll show you how you can expand on that or shrink it. But the deal is as you zoom in, I think it's set to 6 clicks. So as you zoom in to 6 clicks, you zoom past the map into augmented reality mode. You're still in the web browser, but now you can see that pin that's at your location. In this screenshot, there's a pirate ship floating in front of my house that's been there for about a year. So it's kind of cool. I can walk outside, see it on my map, and zoom in and test it. So that's pretty cool. If you've got, like I mentioned, AR immersive devices like a HoloLens or a Magic Leap set of glasses, you can see the experience right there kind of in translucent form in your space as well. So it works very much like a mobile device, except you've got even better transparency in front of you. So that's pretty cool. Keep that in mind as you're building XARPANET style apps that these devices are very convincing. Now let me walk you through a demo of how like the VR component works of this. So if you go to XARPANET, click enter, you'll be taken to this kind of cyberspace looking world. You give it an address or a destination, like we can say the Mirage in Las Vegas. It'll teleport us there in VR mode so we can see the Mirage, the whole digital twin of that address. So, and to do this, we're using OpenStreetMaps for not only the streets, but also the buildings and trees. It's even pulling in tree data into this digital twin as well. So what we see here is the Mirage. We're standing right outside, I think, the south entrance of the Mirage. And you've got, you don't have the facades, but you've got basic geometry of the buildings and the actual locations of where you're at. So you can kind of walk around, the street, what have you. Notice in the address bar, this is the lat long of the address. So you can copy that and share that with a friend. Let me kind of make these different sizes, these browser windows. And you'll notice that as this one loads up in this video, the WebRTC will kick in. We'll start seeing the other person's avatar. You're first person, so you don't see yourself, but you'll see the other avatar. Like I can see the green one just popped up over there. So if we, walk up over to it, let's look at this one. Let's rotate to it. Oh, look, and as we rotate, see the little green avatar on the left? His eyes are starting to come into focus. So there we can go see the other guy's avatar, and you can have, conversations. See, he's turning there. So you could talk to each other in WebRTC and notice the eyes and move around on the sphere as your headset would move, or as you look around the scene. So that's a quick demo of the VR browser running in WebXR in XArpanet's digital twin cities with real-time avatar WebRTC co-presence. Now we'll
Okay,
pause
so
for
before we
any.
pause, I saw the question about international GPS locations. I want to show a quick, a couple of other demos. I realized that this demo didn't have any of the XR Cloud pins. So I'll show you like what a video looks like that I have pinned in Times Square. And then I'll show you a GLTF 3D model I have pinned underneath the Eiffel Tower. So let me show you those just real fast. Here, let me share this screen. Cool. So if you go to xarp.net, click enter, you'll get this address thing. So if I go to Times Square, you just start typing and it auto, tries to find the lat longs of the addresses or reference points you have in mind. And you'll see this is a BTS K-pop video. I put, oh, hang on, why the buildings didn't load. Hang on, let me refresh. Sometimes it hits the OpenStreetMaps API and it takes longer for those to load for some reason. So we got the map, where are the buildings? So that's an example of a video pinned to a lat long in Times Square. Let me go to the Eiffel Tower real quick. I have a 30-foot tall Pikachu pinned underneath the Eiffel Tower. And if you were in person there, you would see it on your map as a actual pin that you could go into AR mode in the browser, WebXR, and see this little Pikachu. I don't know why the Eiffel Tower and the buildings didn't load. Let me refresh one more time. It was working this morning. I think it's just taking a while. There it goes. I think it just took a little while. I was being impatient. So if you look around, there's the Eiffel Tower behind us, behind the Pikachu. And as I mentioned earlier, there's no facade, but they are geometrically and proportionately accurate. All of these buildings, even the trees, are actual tree sizes of actual trees in the space. And so is the street and the map. But that's a 30-foot tall Pikachu pinned in our XR cloud that you can see both in VR. Like if you teleport there, you could click on the little VR icon below and you would get a fully immersive 360-degree experience with your Oculus or Vive. And again, if you had a mobile tablet or a phone and you were physically there, you would see this 30-foot tall Pikachu under the Eiffel Tower. So let me pause for questions here, and then we can move on to the next set of tech stack components.
Chris, do you have any plans for like integrating something more high fidelity like cesium or Esri?
So we have there's a gentleman in Germany that has a much higher fidelity set of tiles that he was interested in collaborating with us. So I think it's just a matter of time, to get all this in, because you'll see at the end, I'm also dabbling with a metaverses.io platform and a grouproom.io platform. So it's all kind of starting to come together. So like XArpanet was really outdoors only. Then metaverses.io is indoors kind of only. So I think that there's an opportunity to start connecting these, and we can certainly go much higher fidelity. The German developers got an amazing set of tiles that do have the facades, and even like things like street lights and street park benches and other types of assets that are in OpenStreetMap. So yeah, stay tuned, and really we're looking for feedback. So I mean, if that's like a killer feature of something you're trying to build on XArpanet, let us know.
It's really impressive.
Oh, thank you. Any other questions? Okay, I'm going to go into the second part of the stack. Hang on.
I think there is another question
Oh.
in the chat.
Let me get there.
He's asking, what is the threshold limit of the longevity of the pinned Pikachu?
There is none at the moment. Like I mentioned earlier, you may not have caught that pirate ship that's out in front of my house. It's been there for a year. That Pikachu, I think, was the first pin I ever did. So it's been probably a year and a half since that's been out there. So we currently don't have any cleanup processes that run. They're indefinite at the moment. And again, any lat long in the world. And so far we support GLTFs and videos. So you can have a big video like in Times Square, like I showed her a minute ago. Okay, let me show the second part of the stack. The messaging component, spatial messaging.
Okay, so let's talk about our vicinity spatial messaging component of the XARPANET platform. As I mentioned earlier, this technology uses real-time IoT-based MQTT communications protocols, which means it can scale to billions of entities, devices, people, anchors, all chatting or chirping at the same time. And the way it works is those messages are pinned to the locations where they are chatting from or connected to. And then any bypassers, either teleported or physically in those lat long areas that are within their listening radiuses, can hear any of those spatial messages happening in that vicinity. So imagine this. Imagine if everything was connected to XARPANET, whether it be people, cars, street lights, etc. As they chirp, like their lat longs or their status or state, like green light, red light, yellow light, those messages could be filtered or heard in that area. So someone in that area could say, I'm crossing the street, let me hear, if there's, or cars could say, let me hear if there's any person crossing the street or any people in my vicinity, maybe that are in my space that I need to be aware of. Same with lights changing colors, from green to red, the cars could be listening to the lights in the vicinity, etc. So pretty interesting concept that scales, world scale, IoT scale, to billions of devices and things with location or presence in mind. So imagine this. So remember I mentioned earlier the listening radius can be adjusted. So the way the XR browsers work is you've got a little slider here, which you'll see in a second, that you can scale down to 1 meter or up to 5 meters of listening radius to hear things in that your vicinity, or to see things in your vicinity, like those GLTF based spatial anchors that could be pinned, which we'll get to also in a moment. But imagine hashtags, or being able to filter by different devices, or just listen to everyone happening at the same time at a programmatic level, and then have your spatial apps react when they either hear events or hear communications that need to be presented to a user or to yet another IoT device. So imagine things like transponders, of things moving around certain spaces, or sharing events or news of things happening in your vicinity. So maybe a concert nearby, or a bicycle race about to start, that's a block away, or maybe messages being able to include hashtags so that you could listen to subsets of spatial messages in your area with concerts as a hashtag, for instance, in your area. So here's what the mobile XR browser looks like from a messaging perspective. So you saw the pin and the radius earlier, but if you click on the ability to chat, you open up the chat dialog, and now you can adjust the slider. That the slider here at the bottom is where you set the 1 meter to 5 meter listening radius. You can enter something like nearby comms, hit send, and then any other user in that area would see that communication automatically chirp. So, here's just some ideas of where this might be useful. Maybe being able to chat with friends all in the same location, like say at a concert or a nightclub, or the Olympics or your school, or even more interesting, maybe like natural disasters. Being able to have this alternative communications platform, this vicinity or spatially aware messaging platform for natural disasters, not only for people physically in the area, but also people that teleport, through VR to that space as well, being able to communicate not only as avatars with real-time communications, RTC in the web, but also from a text messaging perspective. So here's some other ideas. You could develop your own Pokemon game. You could develop something like if here, then do this type of an application all around these events and messaging. So here's a demonstration. If we open up our browsers, okay, here, so you can see you can adjust your listening radius, make it really wide. You can say hello, and it pops up in your listening radius. This one could also do the same, 1, 2, 3. So you can use this purely on an API-based perspective, and I'll show you how that works in a moment. So now we'll pause for any questions related to spatial messaging.
Cool. So we'll pause, and any questions regarding the spatial messaging or MQTT in general, or I mean, that could be a business in and of itself. Yes, it is all public. Yeah. Yep. And you'll see, I'm going to get into the APIs here in a moment, and there is no API key or anything at the moment, so it's really public.
And then do you have any plans for, permissions based, or like this group of people can, hear my messages, but this group can't?
Yeah. So when we were working on the Magicverse and dreaming about what does it look like when at world scale, when you've got like Twitter level membership or Facebook membership levels, and you've got everyone putting models or pins or anchors or graffitis on walls. What the plan is going to be is that you could subscribe to friends channels or businesses like Starbucks that you're interested in, just like Twitter. And then you would only see those layers, if you will, messages, anchors, videos, what have you, of only things you subscribe to. So that's on the roadmap. That keeps everything really clean too, and what you're interested in, you don't see the ugly in the world if you don't want. All right, I think there's just 2 more sections left. One is a really cool, there's 3 sections. So there's a web crawler that we've got to make it really easy to bridge, the current landscape of Web 2.0, Web 1, Web 2.0 websites with the spatial web. And then we'll talk about we'll do a deep dive on the APIs and then a closing. So here's the web crawler we have. Let me show you how it works.
As mentioned earlier, we also have a web crawler to help that transition from, screen-based Web 2.0 websites to this new Web 3.0 spatial web. And it's pretty easy the way we've engineered this. All you need to do is create a spatial.json file. that looks like this one here. I'll walk you through it in a second. Submit your, oh, and then put this on your website, like in the root directory of your, your public folder of your website, and then submit your website's domain here. And just like the old days of Google and, Bing, registering your site to be crawled, that's what we've created here. So every hour we'll go out and crawl all of the domains that are submitted to us, looking for this spatial.json file, and then automatically register all of those GLTFs to those lat longs in that spatial.json file and create those pins automatically for you. So what's cool about this is, if someone's walking around in your area, say you own like a restaurant or something like that, you could have your logo, floating above your restaurant, or and so if someone's looking at the XARPANET browser, they'll see your pin show up at your lat long, and as they zoom in, start holding their phone, looking around their area, then they'll see like whatever the GLTF is that you pinned. It could be your logo, could be a dragon, flying in the sky above your restaurant. But this is how it works. So there's a couple of main elements of this JSON. One is the domain, one is your contact information, your email, and then there's an array of locations. This is the important one. In that array of locations, it's an array of objects. So you're going to have the name of your location. Like in this instance, I've just put HQ, but it's free form. You can have anything in there. This would be the web address, the like Web 2.0 address. You've got another object in here, or element inside this object called GPS, and that's where you're going to give it the lat and long coordinates. You're going to also give it a type of media that you're pinning. Like most people are doing GLTF, but you can also do video as a type, all lowercase. This is the URL of the media asset. So you have to host your own GLTF or your own video, your MP4 or this GLTF. But this is the URI or URL of your media. These services aren't currently being used, but you could kind of create an array of hashtags around the services. And then the anchor, this is also the GLTF of your spatial anchor. The skin and the ads aren't being used yet either, but that's all you do. You create this spatial.json file. You add it to your public site, like the root of your website, and then submit your domain to be crawled. So once that's in there, as I mentioned earlier, we crawl that, we add it to our XR cloud, and immediately it's accessible in any of our XR browsers. So whether your VR or AR, immersive, or even just mobile devices or laptop, and you're teleporting, to those areas, all of those spatial anchors automatically show up as we crawl, and updates. So if you update your spatial.json every hour, we'll crawl it, grab your new GLTFs, your new lat longs, or additions to your existing anchors, and add those to the XR cloud for you to make it easier to facilitate growing the spatial web from Web 2.0 to Web 3.0. So we'll pause for any questions.
I should probably add something also there, is that you'll see the API next. We're going to do a walkthrough of that, but this is a cheat way to like not have to post, like anchor APIs. Like you could just create this spatial.json, put it on a website, and there's currently no limit to the number of anchors you can put in the array, and you can just put it up there and change it at will, and every hour we'll crawl it and update our XR cloud with your data. Any questions about our web crawler? All right, the moment you've been waiting for. Let me show you the XARPANET Spatial Web API.
Okay, now we're going to talk about XARPANET's Spatial Web API. If you go to xarpa.net and click on the developer link in the navigation, you'll land on the page that walks you through getting started with our Spatial Web API. There's a summary here of like all the types of connections you can make with our API and the XR browsers, our XR cloud, even our crawler kind of in reference here. But more importantly, and there's the video we showed you earlier, but more importantly, here's a walkthrough on the API. There's four endpoints. There's an anchors endpoint, the messaging endpoint, players for finding who's where, and then a utilities endpoint to do some conversion between lat longs and geohashes, which is what we use to create like an elevation around a particular pin or lat long that lets you change your listening radius. So there's four PDFs. They're right here. So if you like click on the Spatial Anchors PDF, it'll walk you through like all the curls related to each, creating an anchor, putting an anchor somewhere, listing anchors, deleting an anchor. There's currently no developer API keys involved, so you can just get started right away by experimenting with these curls and the parameters given in each PDF. But I'm going to walk you through Postman, and we'll do some of this. So, as I mentioned earlier, everything's based on GeoHash. So, if you find like the lat long of where you want to put something, if you go to the utils PDF, I've got it here in Postman. You can put in like the lat long and the precision, which is the how zoomed in do you want to be on the geohash. You go to Wikipedia, read up on geohash, and this will make more sense. So, like if we put in this lat long and this geo position or precision, hit send, it'll give you back the geohash to use for either querying players in this vicinity with this, in this listening radius of 6, or maybe getting all the anchors in this listening radius. So let's do that. Let's go to the anchors API, put in the geohash we just gave it. You can put in any precision layer level. The more precise is more values or more characters in the value. So if we send on that get anchors request, we get back an array of all the anchors in this vicinity. You can kind of see what they are, like there's a video pinned to this lat long. We could post an anchor just as easily. Here's an example of how you would do it. You give it the lat long, you tell it it's a type video or GLTF as explained in the PDF, and then give it the URL of where that video or GLTF is hosted. So we'll go ahead and post one just for fun. It tells us it's there. Here's the ID of the spatial hash. I'm gonna copy that. Now if I go back to get anchors in that area, you see it added another video. So there's 2 objects now in that video. And there's that ID of that one. So let's go ahead and delete that anchor by putting in the ID, hitting send. And now if we go back to anchors, submit that, you'll see there's only one video now at that lat long. So that's kind of cool. If you want to see like if there's any players in the vicinity, we come here, we give it the let's see. Oh, so if you don't pass it any values, it'll return all the players in the system. So it looks like there's one player at this geohash and lat long. So you can programmatically add players or remove players, by ID on the system. So you can use our API basically as the MMO of your players, and even move players around if you want. These could be virtual players, by using this as well. Like if you want to simulate like a game and put some virtual players in a space and move them around, you can use this API to do that. The messaging API is pretty straightforward with one little caveat. When you post a message, this is the topic is the geohash and precision, and you are going to want to delineate or break that geohash up by slashes. That's how the browser, that's what the browser uses to like wildcard um, uh, messages in the spatial area. So as say it only goes like a precision 6, then it would maybe only listen for messages like, you know, up to that 6th character. But you basically give it the full precision geohash delineated by slashes, give it the message you want to give it, hit post, and there you go. There's the message that was posted. This quality of service can do just real time, or it can also do level 3, which is guaranteed delivery of messages. Even if someone is offline or maybe a mobile device and they're out of cell range, they'll get the message as soon as they get back online. So that's part of that whole MQTT IoT based messaging protocol we're just leveraging here. So that's kind of the sum of it. You got players, messages, anchors, and utilities for converting lat longs and geohashes into one or the other. And then how you would kind of put this together, you could kind of, going back to my slide deck, you could kind of think about this as the XR browser is what drives the user experience. So, you know, all devices, as we showed you earlier, you could look at the vicinity engine as really what is managing the XR cloud and the messages, you know, all based on lat longs. And then what you would be writing is your own spatial app engine, if you will, that would be adding anchors or removing anchors, or maybe say you wanted to move this little GLTF character around in both VR and AR. You could just animate, you know, adding the GLTF, removing the GLTF, moving it, you know, a step or two, you know, by a lat long, and then adding it again, removing it again. So that's all in real time. So as the players with their XR browsers are in the worlds, you could be sending, you know, messages, moving GLTFs around, and interacting with players, all using the XARPANET spatial web platform and its APIs by writing your own app that interfaces with that. So I'll pause again for any Q&A.
It's like a fire hose. You're getting a lot of information. Let's see. So does the application detect other players? So the player needs to be in the browser. So the players are purely driven by that. I think we're using Firebase, if I'm not mistaken. So all the players are in real time in Firebase. All of the anchors are in real time in Firebase. So if someone is in an XR browser, their player data is live in Firebase, real time. So you'll see as that player moves, you know, lat longs by a step. And then you could also, as I mentioned earlier, through the API, you could have virtual players, you know, also moving around step by step. And even when you update anchors, like I mentioned, animating anchors, that's all real time through Firebase in our XR browsers. So if you move that 30-foot tall Pikachu out in front of the Eiffel Tower like a giant step, everyone who's in VR, who's teleported in Paris or physically there, see that Pikachu move a step in real time. So that's kind of, I would love to see someone write like a real like spatial app that has some interesting like Pokemon style XR game. I think would be a really clever AWE challenge. And Bhaskar mentioned something about a crime scene type of an app too. You could do something very similar like that, or an escape room, like a world escape room or a scavenger hunt or something like that with this as well. That could be very interesting too. Any other API questions? We've got one more kind of closing that introduces our kind of some sister projects, our metaverses.io and grouproom.io. And I'm really excited to see, and I'm thinking about this too, is that XARPANET's mainly an outdoor, app that uses GPS. GPS does not work indoors. So what you'll see coming up is metaverses.io is really an indoor metaverse, platform. You could do outdoor with it too, but I'm starting to think about maybe as you go through a door, like you're in XARPANET and you see all your buildings, and maybe you walk into a building that could maybe transition you to metaverses.io space. You'll see what I'm talking about in a minute. And then when you leave, when you go out the door, you're back in XARPANET, in front of the building you stepped into. So kind of playing with some ideas of kind of merging some of these sister projects into one big one. So I guess let's jump into that one, and then we'll have time for more Q&A. So let me show you. Let's do the closing.
Okay, last but certainly not least, on the developer page of XARPANET, at the very bottom of the page, it also mentions that we've got two sister projects, if you will, one called metaverses.io and one called grouproom.io, which are basically metaverses with real video chat avatars that can move around, 3D spaces, metaverses that you build and host your own metaverses at will, 3D as well as like 2D group rooms. So real quickly, let me just walk you through what those look like, just in case you're interested in maybe doing something with them as well. They both have a REST API and a WebSocket API as well. So hit me up, Chris at xarpa.net, if you're interested in accessing metaverses.io or grouproom.io's APIs. But if you go to metaverses.io, you can kind of see here, it's a very similar to the spatial.json file. There's a metaverse.json file that you can create, your define your GLT assets, your A-frame entities. We're using A-frame, by the way, but we've just JSONized it. And then your embeds. That's not part of the A-frame API, but we've added the ability to, like you would embed GLTF in the real world, you can embed, GLTFs or videos or web content in the 3D metaverses space by doing that there. You can explore samples or examples of how to create your own metaverse. You host that metaverse.json file on your own website, and you can explore what other people have been building with it as well. So, and these are all real-time thumbnails, so you can kind of look around. Like this one's a pool metaverse, so let's go there. Let's click on it. It'll show you who's in the verse at the moment. You can join. There's no one in this one, obviously. Asks you to sign in with your Gmail or an email address. It'll ask you to select your audio, your mic and camera, and give permissions. This is really important, how to move around. WASD is left, right, forwards, and backwards. And then this IJKL is your rotation and panning joystick. So this is it. So that's me. I'm a video avatar instead of that silly little spear with eyes. And you can just move around, your space here and interact with people near you. So this is a pretty cool way to create and host your own metaverse space. So there's plenty of, as I mentioned, WebSocket APIs and REST APIs. So hit me up if you're interested. I'd love to see ideas on connecting like metaverses.io with XARPANET. Show you what group room looks like. It's instead of 3D, it's 2D. So here's like, you create a room, you upload a really big image. I'm going to use this default one here to show you how it works. So we're gonna give it permissions to mic and camera, and now it's just 2D representation of your animation of your video chat bubble moving around the space. Again, there's REST APIs and WebSocket APIs available for this as well. So I'd love to see what you have in mind on how you could interface with GroupRoom.io or Metaverses.io and tie all of that in together in the spatial web with XARPANET's APIs and browser and crawler and spatial messaging platforms. So my contact information is here. I mentioned it earlier, but you can hit us up at XARPANET or chris@xarpa.net. Looking forward to seeing what you guys build, and let me know if you have any questions. We also have a Discord channel. It's just search for XARPANET as Discord, if that's easier for you as well, or feel free to hit us up on Twitter, as I mentioned there as well. So thanks a lot for sitting through this XARPANET presentation. We're looking forward to seeing what you build for the AWE challenge. Hack the planet.
That's all she wrote. Any other questions that you guys may have about the platform or ideas you want to validate? Let's see, there's some chats. Let's see. Oh, thank you. Love the pick. Yeah, that was from Magic Leap's Leap conference. Well, I've really appreciated the opportunity to be on this AWE challenge journey with you guys. I'm here hacking usually most of the time. Just hit me up on Twitter or Discord or email, and I'll help you the best I can to move your cool project along.
Thank you, Chris. It's really impressive.
Oh, thank you, Suzanne. That
Yeah.
means a lot to me coming from you. I appreciate that. You've seen a lot.
It's really cool. Yeah.
Cool. Thank you.
Okay. I'm going to end the recording.